Welcome to the next installment of the fundamental videos. This time we are looking at how to process your data. The first thing we need to do is state what the relationship is. So last time we drew some error bars and got this graph, and the shape would suggest that it is a square root relationship. The best place to look though in terms of the relationship is the formula on the front of the booklet. And here you can see that t is equal to all this stuff, and up here is square root of L. So we know that t is proportional to the square root of L. So the graph and the formula suggest it's a square root relationship. So what we need to do up here in this box is write in words, time period of the pendulum is proportional to the square root of length. So for some reason this needs to be in words. You can't just write t fish square root L, even though it says exactly the same thing. Okay, so what we're going to be looking at is how can we transform these values here of L into square root of L values. That's probably pretty straightforward if you did physics 2.1. Now we have to consider the uncertainties here as well and how we transform those. So let's have a quick look at what it means basically. So you can kind of consider your error bars in a way from last time. So for each L value you can have an error bar like this. If this is L, this point up here is L plus the uncertainty, and this point down here is L minus the uncertainty. And what we want to do is transform all of this data onto another axis. This time we're transforming it onto the square root of L axis. So it's going to end up somewhere else. Remember, these are different scales, so it doesn't really matter where I put these, but it's going to be different in some way. Here, this value here, to get from here to here, all we need to do is square root this value. Okay, so if we square root the L value, we end up here with a new value, which is square root of L. And we can do the same thing up here. If we square root each of these values, so the value plus the uncertainty and the value minus the uncertainty, we end up with new values on this new axis. So here this will be L plus uncertainty square rooted, and this is L minus the uncertainty. So what we need to consider is this distance between L here and L plus uncertainty is the uncertainty. And in this case, if we look back at our data table here, the uncertainty as in L is plus or minus 0.003. So on this side it is plus 0.003. And on this side it is minus 0.003. So if we transform the L values, and we just transform, we only need to do one of these. I'm just going to do the L plus the uncertainty. We can then get the new uncertainty in the square root of L by finding this. So this distance here, I guess, or the difference between these two values is the uncertainty, or the positive uncertainty in square root of L. And this is the value that we want to work out, and we're going to put it here into our data table. Okay, so let's have a look at what that looks like. For this we're going to need your calculator. Hopefully this will show up on here. Oh yeah, there we go, good. Alright, so in here this is going to be square root of L. Remember, if you're square rooting the value, you also need to square root the units. So that becomes square root of meters. Here we have one uncertainty for all of the L values, here, after transforming them, we're going to have a different uncertainty for each of the values. Okay, now I'm going to show my working down here for the first value. So what I need to do first is square root of L, it's equal to square root of 0.100. Bung that into my calculator. Do it right. And I get 0.3162277666. That's a bit overkill, and we'll look at rounding this later on. So now I need to look at my L plus uncertainty. So that's going to be equal to 0.100 plus 0.003, okay, which is equal to 0.103 square rooted. So back to my calculator, square root of 0.103 equals 0.32093613, and so on. Okay, so then I can find my uncertainty in this first L value. That can be shown as delta square root L. So the uncertainty is what delta means now, the uncertainty in the square root of L. And that's equal to difference in these two values. So the difference in L plus the uncertainty and L, which is just to find the difference is always to subtract. So I'm going to put these numbers in here. So first this one, and then I'm going to subtract this one from it. Now you're probably thinking, gosh, that's a lot of numbers that you're writing out there. Wouldn't it be better just to do this in your calculator? And it is. So I'm just going to go back and do this from scratch. So start with square root of 0.103. I'm going to subtract off that the square root of 0.10. Cool, and this is my uncertainty in the square root of L. Cool, so 10 to the negative 3, I'm going to move that 3 places, all that way. So that's equal to 0.005. Remember, I need to round this to one significant figure. Cool. Because your uncertainties are always rounded to one significant figure. That goes in here, plus or minus 0.005. And this value here, which is the square root of L, goes up here, and now I can round this to the same number of decimal places as the uncertainty. So this is 3 decimal places here. This can now be rounded to 3 decimal places also. 0.316. Great. So I'm going to go ahead and do the rest of these now. So now I've finished calculating all my uncertainties in my square root of L values. I actually find it faster to go through and calculate all of the uncertainties first, and then go through and calculate the square root of L values, but that way you can round them as you go, because you need to round these to the same number of decimal places as the uncertainty. And remember, your uncertainty is always rounded to one significant figure. Cool. That's all for this video. Next time what we're going to be doing is graphing these values here and drawing some error bars for that. I'm not going to do a video for that, so you can go ahead and graph it, but I will do a video for drawing the line of best fit and the line of worst fit. So we can use those two lines to work out an equation and also quantify the uncertainty in both the gradient and the y-intercept in our equation. Hope this has been helpful.